So this video will be a quick review of absolute value inequalities. So this is just a review of the setup and solving in general. To keep this video quick, I am not going to review the special cases like when absolute value inequalities are greater than or less than or 0. So we're just going to talk about the general setup because most people forget that. So first of all, there's really just two situations with absolute value inequalities. So the first situation is when you have an absolute value inequality less than something, and that could be less than or equal to. So if you're in this less than direction, and the absolute value inequality has to be on the left, by the way, when you have this situation, to set this up, what you're going to do is you're going to set up a three-part inequality. So it looks like this. So it's negative c is less than ax plus b is less than c. So this part gets broken off onto both sides, and then one side is positive, one side is negative. Whatever sign you have here, you carry that down into here. So if this were a less than or equal to, these would be less than or equal to. So this is the setup, and then you can go from there to solve for x, okay? So this is setup number one. Setup number two is the case where you have your absolute value inequality still on the left, but now you have a greater than sign. So it could be greater than or equal to. So when this happens, you break this into two inequalities. The first one is just ax plus b is greater than c, and then we set up, it's a compound inequality, so there's an or, and then it's ax plus b is less than negative c. So notice now that I both flipped the inequality and I made c negative. Once again, if this were a greater than or equal to, then these would have an or equal to sign on them. Okay, so these are really the two setups. You have the case where we are in the less than case and it's a three-part inequality, or you have the greater than case and then it's a compound inequality. So the thing about this is that the absolute value needs to be on the left. So it's not on the left, then your setup is not going to be right. So you just want to also rewrite your problem so that the absolute value is always on the left. So now what we're going to do is we're just going to go through like 4 of these. And again, there are some special cases, but I am going to omit those just to keep this video short. I have lots of other videos on the special cases if you need to see that. But I think a lot of times people just need a quick review of like how to solve these in general. Okay, so I have the absolute value of 4x minus 2 is less than 8. So this would be the less than situation. And so then I'm going to set up this three-part inequality, okay? So this setup is going to be negative 8 is less than 4x minus 2 is less than 8. Okay, so now we can go through and solve for x. So I just think of how do I get x by itself? So first I'm going to add 2, and I'm going to add 2 to all sides. So this becomes negative 6 is less than 4x is less than 10. And then I can divide all sides by 4. And so then I'm going to have negative 3 over 2 is less than x is less than 5 over 2. And then depending on what you're doing with this, there's different ways you can represent your solution set. So I am going to also omit all those different ways, but I'll show you one way we can represent the solution set. So one way would be on the number line. So this literally means that x is between these two values. And so on the number line, I just need to make sure that I'm not including these endpoints. And the way that you do not include those are you use an open circle, and then you can just color everything in between. Okay, so let's contrast that then to example B here. So I've got the absolute value of x plus 4 is greater than or equal to 2. So this would be the greater than case. So when it's the greater than case, or in this case greater than or equal to, here is my setup. Okay, so let's go ahead and set this up. So this becomes x plus 4 is greater than or equal to 2, or x plus 4 is less than or equal to negative 2. Okay, and so that's it. So now I just solved these two inequalities separately. So what I'm going to do now is I'll just subtract 4 here, subtract 4 here. So I'm left with x is greater than or equal to negative 2, or x is less than or equal to negative 6. Once again, there's a couple different ways of how you can do the solution set. I will just quickly review how you could do this on a number line. So here's -6, here's -2. In this case, I want to include these numbers in the solution set. So I'm going to use a close dot. And so where is x greater than or equal to -2? That would be this direction. And then here's -6. So where is x less than or equal to -6? That would be this direction. And you can also represent that solution in a couple other ways, but I'm just going to do that one for right now, just so that I've covered it. Okay, so if you are playing along at home here and you're trying to understand this, I would strongly recommend that you try to solve this one totally on your own, just to make sure that you are getting this. Remember, math is not a spectator sport. Pause here, give it a try. Worst that happens is you get it wrong. Okay, so this is a less than or equal to. So this is going to be that 3-part inequality. And okay, so now I can go ahead and subtract the 5 off from each side. So I get that this is -12 is less than or equal to -2x is less than or equal to 2. And then I divide everything by -2. Now, there is another little piece of review in this that you do have to remember. So when I divide everything by -2, since I'm dividing by a negative, these inequality signs need to flip. That's one of the things about inequalities. When you divide or multiply by a negative number, you have to flip the inequality. So this will turn into 6 is greater than or equal to x is greater than or equal to -1. And I think this is a very awkward way to have a solution set. So what I like to do when my inequalities are not going the right way is I like to just rewrite it. So I have -1, x, and 6. So just when you want to flip this, the mouth of the inequality needs to be opening the same way. So the mouth needs to be opening towards the 6 and the x. So there's my solution, and then if I wanted to put it on the number line, so I'm going to include the endpoints in this case, and bada bing, bada boom. There you go. Okay, so I have one more here. So again, if you're playing along at home here and you're trying to review this, strongly recommend that you try this on your own and hit play when you're ready. Okay, so now I'm going to have 3x plus 1 is greater than 7. And since it's a greater than, then it's going to be an or. 3x plus 1 is less than -7. And so now I can go through the work to solve each inequality. So this becomes 3x is greater than 6, or 3x is less than -8. So when I solve this, I get x is greater than 2, or x is less than -8/3. And so let's see, I can do the number line right here. Here's -8/3, here's 2. Open circle, we go this way. Open circle, we go this way. Okay, so as a reminder, so this was meant to just be a very quick review. In the event that you're saying, okay, I have no idea, I was looking for more instruction, I have tons of videos on that. But if you did find this video helpful, I'd love it if you hit that like button or that subscribe button. And otherwise, I will catch you guys in another video. Thanks for watching.